Okay, this next problem is going to be a pretty fun physics problem. So we have a steel ball and it weighs about 2 pounds. So weight is equal to 2 pounds. And then its initial height, so it's at 3,000 feet. Oh god, that's high. So it's at 3,000 feet, and then we're gonna, I guess we're gonna drop it out of the sky and, let it hit someone, right? I don't know why you would ever do that. But you want to know the time that person has till they get hit with a ball out of the sky, you know? So, you know that your resistance is equal to V over 8. Okay? And, yeah, that's about all we're given. So the idea of this problem is that you say the sum of the forces, right? The sum of the forces in the y direction. Here, let me write this better. So the sum of the forces in the y direction. And then we could represent that as MAY is equal to dot, dot, dot. And what's it saying is, okay, so we'll have weight and then we'll have friction, right? Because weight and the air friction, right? So that's what we know. So we're going to use this idea, but before we do that, let's define our problem. So if we say that going down is positive and that going up is negative, the only reason why we would do this is just so we get a positive answer at the end. It doesn't matter. I mean, you could write it negative, but you just need to stay consistent. That's the idea. So the forces acting on the ball will be its weight, and then it will be the resistance, air resistance, right? Okay. So basically what we can do is we say MAY is equal to the weight, and the weight, so again, the weight's positive in this case because it's going down, right? So I'll write vectors next to everything and indicate the minus R, okay? As it falls, the ball encounters an air resistance equal to V over 8 minus R. Okay. So for us, what we should do is we should write everything in terms of some common variables, and that common variable being velocity. V equals velocity. Okay, so if we write everything, then we could write this as M. I'm going to erase this now. We could write this as M. Oh no, this looks so bad. MdVdt is equal to, great, my screen's not big, there we go. So M is equal to dV dt, and then weight is just going to be 2, because it's literally a constant, right? Weight is not changing here in this case. And then R is going to be V over 8. So what does this look like? This looks like a differential equation, right? That we can solve. So let's get this in some form that we like. So we go dV dt, and if I add the plus V8 on this side, and then this is equal to 2. And doesn't this look like our classic linear differential equation? So if I divide by M, we get dV dt is equal to V, not equal, is going to be plus V over 2. God, I'm saying all the wrong words today. 8M. And that is equal to 2M. Divided by, is equal to 2 divided by M. God, you guys get what I'm saying. I'm writing it. Okay, and then let's write what M is. M is equal to, so I'm not going to skip, weight is equal to mass times gravity. So M is equal to weight divided by gravity, right? And the weight is 2, and what is the gravity? Okay, now gravity in feet per second is 32.2. It's 32.2, so if we write it, my screen's not loading. Oh no, still not ready. Okay, sorry, I was having some technical difficulties. My screen was not showing you guys everything I was writing. Okay, so what I was saying is if we use this relationship, weight is equal to mass times gravity, and then if we solve for mass, because we need to, we get 1 over 16. Right? So now let's rewrite this equation in a little bit of a more nicer form. So it's going to be dV dt is plus, and then V, okay, so 1 over M, let me just write it up here, 1 over M is 1 divided by 1 over 16, which is 16. So what we have here is going to be V, and then divided by 8 times 16. So it's going to be V 2V. And then on the other side, it's going to be, what, 2 divided by 16. I mean, 2 divided by mass, which is 2 divided by 1 divided by 16, which is 32. Okay. That's all it was. That's all. It sounded confusing, but It's just because there's a fraction and you have to say divided by, right? Okay, so if we solve our linear equation here, and we need an integrating constant, we'll call it mu of t. So mu of t will be whatever this number is right here, and we're going to take its, not mu of t is going to equal that, we're going to use this number here to find mu of t. So we're going to put it here. Again, just standard integrating factor here. So this is what we get. Okay, so then we know that the solution to our differential equation will be in the form like this, right? It'll be v and then times mu of t is equal to the integral of mu of t f of t dt. And I get that because I know that my, usually if we have like a y and x, I made a lot of videos on this. The shortcut to the linear equation using y and x is mu of x times mu of x f of x dx. All I did is just change the variables, right? I made a lot of videos on linear equations, but if you're solving these problems, linear equations shouldn't be that bad to you right now. Okay, let's just fill in these gaps here. So mu of t is e2 of the t. And then f of t is 32. So times 32 dt. So if we do this, we get, so it's going to become, you take this, right? Take its antiderivative, it's going to be divided by 2. So it's 32 divided by 2, which is 16 e to the 2t plus some constant c that we don't know. Okay, so we want to find v, and v is equal to this thing, but divided by mu of t. And mu of t is e to the 2t. So we get 1 over e to the 2t divided by times 16 e to the 2t plus c. So what we get is we get 16 plus c e to the negative 2t. Okay, so this is our answer. This tells us the velocity coming down to the ground, which is really nice. Okay, but we don't know the time it takes. So what we can do is we need to solve for that initial condition. So if we know that v of what? Well, actually, we can't really solve for everything yet because, like I said, we don't know the constant, and all we know is that at our initial condition, t was equal to 0, and assuming that the velocity was equal to 0. So if we do this, now we can solve. So 0, because velocity at t equals 0, 0, 16, and then this is c e to the 0, so c, just c by itself. So you see that c is equal to negative 16. Okay, so that's good. So you get v is equal to, I'm going to factor out the 16 here, 1 minus 16, it's going to be 1 minus e to the negative 2t. So this is your velocity here. Now, again, you want to find the time it takes for it to hit the ground. Does this tell you the time it takes to hit the ground? No, it doesn't. It just tells you how fast you're going to be going. So what we need to do here is we need to use this. We need to know that the velocity is equal to dy dt. Okay, and then what we want is we want to find y. So we go dy is equal to what? V dt, right? If we take the integration of both sides, then we can start getting answers that we actually care about. So precisely, we see that y is going to equal to the integration now. V goes from some velocity v to 0. Okay, and this is what our integration here is. So 16, 1 minus e to the negative 2t dt. And if you take this integration correctly, you get 16, and then t minus e to the negative 2t divided by negative 2, and there'll be a negative 2 right here, and there's a negative here, so then you could write this as plus 2 now. Okay. There you go. And you get some constant c that you don't know about. Okay. Now, you apply your initial conditions here again, and you ask yourself, where in the sky were we originally, right? We were originally at 3,000 feet in the sky. Okay, so in the sky to us, like we start at the plane, right? So you're going to jump off a plane, right? So we're originally at 0, and then we're going all the way down 3,000 feet. So initial condition meaning what? Well, it means that we're, 3,000 feet in the sky. So from t equals 0, we're 3,000 feet in the sky. That's why it's negative 3,000. If we were to have this thing the opposite way, it would be positive 3,000, right? But then everything might be a little bit different here. Okay, so negative 3,000, that was equal to y. That's y in the beginning of time. And then 16, and then t's, all the t's become zeros. So all we get is 1 over 2 plus c, which is the same thing as 8 plus c. So we see that c is equal to what? It's negative 3,000 minus 8, which is negative 3,008. So then we could write that y is equal to what? Y is equal to 16t plus e to the negative 2t divided by 2 minus 3,008. Okay, so this is really useful. This equation tells you the time, like it tells you once you jump off that plane. Okay, I'm gonna stop using the skydiving example. When you're on the plane and then you drop the ball, right? You're dropping the ball and it's gonna tell you where the ball is at any moment in the sky if you put in some time for it. So this is your solution here. Okay. Now the question wants to know the time it takes for the ball to hit the ground, though. So the way you can find that is, so y has to equal to 0. So y equals 0 if ball hits the ground, right? Broken English here. Ball hits the ground. Okay, so if that's true, then you go 0 is equal to what? 16t plus e to the negative 2t divided by 2 minus 3,008. And since I've done this problem before, it's like really, really hard to actually solve for time here, even at this stuff, because it's not just simple quadratic. But what you can do is you could cheat a little bit and use a calculator from here, or you can just leave your answer like this, right? And just write this description here for your teacher. Because like if you're in differential equations or in physics, your teacher doesn't want to see you do algebra. Like they want to see you do the setup and get this type of stuff correct. On this part at the end, they are fine with you just leaving it. But I will give you guys an answer because I'm sure you guys want to know. So you get that t is approximately equal to 188 seconds. I'll show you guys what I did. Okay, so I just put it in here like this. And then here you go. This is your answer. So that's the time it takes for the 2-pound ball to hit the ground. So it takes a lot of time for it to hit the ball after being dropped 3,000 feet, which makes sense. Okay, it's like about 3 minutes.